length of a contiguous subarray with equal number of 0 and 1. They gave us two examples here. They give us one example where you have an array, 0 and 1, and the length of that contiguous array of 0 and 1s is 2, right? Because the length of this array is 2. That's one example. A next example is you have an array, you have 3 elements, and you want to get the longest contiguous array of 0s and 1s. So what does that mean? It needs to be 0, 1, 0, 1. In that case, it's not the length, the maximum length is 2. Why? Because 0 and 1 is 2, but 0 here is missing a 1. Does that make sense?
Mm-hmm.
Right? A longest contiguous array could also be 1 and 0. So far, so good?
Gotcha.
So of those two arrays, the longest one is 2, correct?
Mm-hmm.
Right? It would be nice if there were more examples, but here we do not have more examples, right? So the approach here this is one of the questions where you have to, yes, you could brute force it first, but at some point there's some strategy that you could, was there a question? Question? Hello, any questions?
No.
Okay, at some point, doing many of those questions, you'll come around different strategies. For that particular question here, there's a strategy that you could use along with a dictionary to know at what point have you seen a 0 and or a 1, right? In that particular example here, what we'll do, we'll say, if I see a 0, I use a counter. The counter starts at 0. If I see a 0, I decrement my counter by 1. If I see a 1, I increment my counter by 1. So at the end of the day, my longest contiguous array will be the index where I've seen that particular number, that longest index there. So if I've seen it where count is -1 and the longest count is like 6, then that would be the length of the array. That makes more sense if we actually draw it out, because there's not enough examples here to really show a longer array. So actually, let's go to draw it out. Does everybody have like pen and paper?
Yes.
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 So this is contiguous array here. Where's my pencil? Contiguous array, binary. Okay. Anybody want to give me an example? Maybe not too long of an array, but a binary array example.
0, 0, 1, 0.
0,
1,
0,
0.
1, 0, 1, 0, right?
Yeah.
All right. So as I said, the strategy we're going to use is using incrementing or decrementing a counter. We'll be using a counter variable. We'll be using a maximum length variable as well. So that way we could verify what's the maximum subarray of those given indices where I see the count, where I've seen that count before. So what we're going to do is we have the index of the array. We have a counter. And our counter starts at 0. Okay, so far so good?
Yes. Yeah.
Okay, so if I see a 0, what am I doing? What's my counter?
-1.
-1. -1. I see a next 0. What's my counter?
-2.
-2. I see a 1. What's my counter?
-1.
-1. I see a 0. What's my counter?
-2.
-2. Is it mine? Yeah.
Yeah.
I see a 1. What's my counter?
-1.
-1. And I see a 0. What's my counter?
-2.
-2. Right. So here, with the solution or the algorithm that we chose, we said we're looking for the longest contiguous array here. In that case, the longest contiguous array is where that counter appears. In that case, we have a counter of -2 here, -2. And we have a next counter here of -2. So far, so good?
Alex, what do you mean by when the counter appears?
We've seen that index before. If we've seen the index before,
Okay.
go ahead.
Yeah, no, okay.
Yes. So if we've seen that index before, like this is the first time we saw -2, correct?
Yeah.
First time seeing -2. This is the first time we saw -2. We saw -2 here as well, correct?
Yeah.
And we also saw -2 here, correct? So that -2 we saw here, we also have to compare that -2 subarray. We have to compare the two subarrays to see which one is the longest one. And the longest one is going to be the outer one. Do we agree?
Yeah.
Let me draw this differently, different color. So here, this would be the longest subarray where we have zeros and ones. And to achieve our answer here, we would say, go ahead, ask the question.
Yeah, so it's essentially the first time you're seeing it and the last time you're seeing it.
Yes, exactly.
Okay.
So that's why we're going to be using, thank you for bringing that up. That's why we're going to be using a dictionary here to keep track of that. So we'll be using a dictionary to keep track of the count. And what else?
And the index.
And the index. Very good. So here, this is the index 0, 1, 2, 3, 4, 5. Very good. So we have a dictionary to keep track of the count and what index we saw it. That way we could compare which one is longer. Does that make sense?
Yeah.
Okay. So here, once we get to that point, then we could say 5. In that case, 5 is the index minus the first place we saw it here, 1, and then the answer would be 4. So the maximum length would return is 4. And why 4? Because if you take that down here, you get 1, 0, 1, 0.
So you're doing index -1, you said?
Yes, index, well, not index -1 necessarily, but index minus the first index we saw.
Oh, okay,
The
so
current index, so current index minus first seen index, I guess, is a good name. So we have to compare those two. We have to compare the previous maximum length we saw compared to the one we saw before. So in that case, the previous maximum length here would be 2, and this current length would be 4. Everybody sees that?
yeah.
Let me change the colors.
I have a question.
Yep.
Why did we specifically use the counter?
One second. So 2 and 4. Why did we specifically
Use the counter -2 instead of, for example,
go ahead.
like -1 instead of -2. We see -2 3 times as well.
Yeah, that
-1,
that could also be that's a good observation here. I could make it a little messier, but let's see. You're talking about this one here? I'll just circle it instead here.
Yeah.
Right? That would result to the same answer of maximum of 4.
And that would be always, this isn't just like out of chance it happened this way?
No, it's not out of chance. If we have to do the same thing with a different, this was a array randomly from one of you. If we had to do that same pseudocode with a different array, we'd come up with the identical answer. Not identical answer, but the same answer.
I think she's saying, why are we using -2 as like to compare a non-1?
Oh, I could use -1.
Oh, so it's interchangeable, basically.
Yeah, we just chose to use -1, but could have easily done it with -1.
But if you use -1, it would give you 0, 0, 1, 0, 1, which is not a.
No, it will give you this here. It would give you this, because remember, you minus in, if I say the index of 4.
Oh.
If I say index, what's the index here? The last index?
4.
4 minus
1.
One.
Well, minus 0.
Oh yeah, because yes. Okay. Oh, it makes sense.
Cool.
Yeah.
Wait, sorry. Could you go over why you're subtracting 0 instead?
'Cause
0 is the
Oh,
first place
because,
we. Yeah.
okay, right. Gotcha. Okay.
It's a tricky algorithm, but at the end of the day, once you get it down, it becomes easier. But to get to that point, you've had to see NAPAM or done the brute force way and figure out a better optimal way to do it.
Okay, right, because that's the
Yeah,
index.
wait, Alex. Sorry.
Go ahead, Seren.
Is hash the same thing as dictionary? Because I've seen
Yes.
like hash
Yes,
table.
yes,
okay,
yes, yes,
alright.
yes, yes. So we have dictionary here. You'll also see hash table. You'll also see hash map, right? So 1, 2, 3. So you have hash table, you have hash map, you have dictionary. They're all, at the end of the day, a dictionary.
Yeah.
Because a hash table is used to create a dictionary. But they could be used interchangeably, the names themselves.
Okay. Because I asked one of my computer science friend, and he just told me to use a hash table, and I had no idea.
Yeah. What language is he doing? Java?
I have no idea, but he has a class just for DSA, so.
Okay.
I
Yeah,
don't know
hash
what
table is a dictionary.
Okay.
It's good. Because the process of creating a dictionary uses a hash table. Remember, the hash itself is a unique number,
Hashable, yeah.
right? So you hash that's why the key, so when we have a dictionary, the one we'll be using is an int and an int, for example. This here needs to be hashable, correct?
Yeah.
Right? So the whole process of making a dictionary is putting those values in a hash table. And then if I want to do a 5 as a key, I cannot use a 5 again as a key. Like if I have a 5 as a key already, I cannot have someplace else in my dictionary having a 5 as a key. I'll get an error, correct?
Yeah.
Because of the hash table. It says, hey, that key has been used already in the table. I cannot use that key anymore. Right? So that's why they're pretty much interchangeable, because a dictionary is a set of hash keys.
Yep.
Cool.
Alex,
yeah.
Actually, that's where I got a little stuck on with the explanation. It's just like, so we're going to be iterating through this array, right?
Yes.
And as we go, we're changing the value of the count through the index, right?
Yes.
So like, won't at the end how do we get like the first value of the index if
the first value of the index will set it to we'll set the count to 0 and the index to -1 in our dictionary.
So in this example, right?
In any example.
No, I mean, I'm saying specifically for this example right now. The first time we see -2, right, for the count is at index 1, right?
Yes, yes.
So set the dictionary for the count. So dictionary 2 is equal to.
Let's actually do our dictionary. So the dictionary would look something like that. It would start off, as I said, the count would be 0 and the index would be -1 because we haven't seen anything, correct?
Right.
Oh, don't you mean the reverse?
So then it's index count, not count index.
It's count and it's index.
Wait, I
Wait.
think the
Alex.
One second. Go ahead.
because you're saying that the count is -1, -2, -1, -2,
Yep.
but then wouldn't that be the value, not the key?
Well, I kind of showed it here. Like right here, we have the index minus the first index, correct?
But doesn't index start at 0?
When you go through the array?
Yes.
Yeah.
Mhm.
It does start at 0. Our index when we start is going to be -1. But the first time we go through our array, the index will be 0. Whenever we insert in anything, it will be 0.
Okay.
So for example, when we see, what's the first one we see? When we see a count of -1, because we haven't seen it yet, correct? Over here, the count will be 0. Oh, sorry, the index will be 0, correct?
Yes.
Okay, next time, what do we see? -2. What's the count for this guy? Oh, what's the index for this guy? 1, correct?
1.
Yep.
What's the other one? That's it? That's it. So when we're about to say, okay, now I want to find out what's the maximum length of the thing I'm looking at, right? In that case, for the -2 here, I look up here for the -2, for example, in my dictionary, and it tells me, hey, the index where I saw -2 first was at index 1.
Oh,
So we're using the dictionary only for the purposes of knowing the first place we saw that count.
Alex?
Yep.
If we, so, wait, okay, so the first one is -1, the index, right?
Mm-hmm.
So that would be applicable for every single array that we encounter?
Yes.
Okay. So we're just starting with -1 then?
We started with -1, yep.
Okay.
Because we haven't seen anything. Ahad, does that
Yeah.
help you?
Um,
As we go through the solution, it might be more apparent, but we'll come back to the illustration later.
okay.
All right, let's go through the code part of it, and then we'll come back to the pseudocode part of it. Let us. I'll just use the same sort of. Can everybody see my Xcode correctly, or should I make it bigger?
I see it.
Okay, so let's start out with the function definition. I'll use the same one they have here. Find max length. Takes in an array of numbers and returns an integer. Okay. So we said we need some variables. We need a counter. We'll just call it count here. We need a max length return. Start off with 0. We'll just return max length here. And we said we needed a dictionary. I'll just call it frequency dictionary. And we said the key is going to be an integer, which is the count, and the value will be an index. So here we have count and index. And the purposes of this dictionary here is to know the first time I saw this count. If I've seen the count before, that means I'm in a subarray. So if we have seen the count, subarray.
I'm sorry, can you actually make it a little bit bigger?
Okay, sure. Whoa, not that. Like this. Is that good? Is that good?
Yeah.
Cassandra,
Yes,
you want it bigger or are you good?
I think that's good. Thank
Okay,
you.
all right. Okay, so now we have the variables we need. Let's go through the array now. And we need the index here for the array. And we'll call it num in nums.enumerated. Everybody remember enumerated, right?
Yeah,
Right.
Yeah.
So if I want to get
that's
access.
the least of our problems at this point now.
Okay.
Enumerated.
All right.
Attitude.
No, not attitude.
Okay. All right. So in our algorithm here, we said, where are you? Where did we go? Weird. Just die into the ether. Oh, okay. Let me put it on a different screen. Right here. Okay. Right here, we said we're using a counter. We're using a counter. We decrement in the counter. We see a 0, correct?
Mm-hmm.
Yeah.
Everybody with me so far?
Yes.
We decremented the counter. Okay, so in here we'll say if num equal to count well, not count, but if num equal to 0, what do we want to do?
Index, just decrease it.
Decrease the count.
Decrease the count, right? So
By 1.
count minus equal to 1, correct?
Yeah.
Else, what do we do?
Count plus
Increment.
plus
Count.
equals 1.
Plus equal 1. So far, so good?
Yeah.
Okay, so we've taken care of our counter. What's the next thing we need to do here? We need to keep track. We need to use our dictionary here. Where is it? We need to use our dictionary here now to keep track of the counts. If we've seen the count before, we want to put it in our dictionary. Or if we've seen the count before, we want to find out the maximum. We want to find out the maximum length of that subarray, which is this guy. So 1. And if we haven't seen it before, we want to add it to the dictionary. So 2 steps. Step 1, if I've seen it before, I want to find out the maximum of that count of that subarray. Let me make this disappear. Basically, if I've seen the count before, I want to find out the 2 differences between what's the maximum between 2 and 4, and set that to my maximum length. Everybody with me? If I've seen the count before, in that case, if I'm here, assuming like we're at the end of our array, right? In that case, if I'm seeing -2 here, I want to find out what's the maximum subarray. Everybody with me?
So the idea is that once we hit -2, it means that there's been a pair.
Yes, I see -2 here. I see -2 here. I want to find out, is maximum length longer than what I'm seeing currently?
Right.
When we first start, what's maximum length?
0.
0.
0. When I see a -2 there, do I do anything? The first -2 I see?
No.
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 When I see the second -2, we want to do some logic. We want to say, okay, I've seen -2 before. So now I want to find out, is that length longer than the length I have currently? That's all we want to do. And keep doing that same logic until we finish with the array. So currently, let's walk through it. Currently, what's maximum length?
0.
0. When I get here, if I compare 0 with 2, what should be the return value between maximum?
2.
You
2.
reset maximum to 2.
It should be 2, right? Now my maximum length will be what?
2.
2. I keep going through my array. When I get to this other -2 here, what is the maximum length currently?
4.
Currently it's 2, but then you have to reassign it to 4.
Currently it's 2. Then I would need to compare 2 versus 4 and return the maximum of those 2 values.
Yeah.
And then it's going to be 4, correct?
Yeah, I get that, Alex, but my question is like, what's the significance of the numbers like being repeated, right?
Oh, you mean what's the significance of those guys being repeated?
Yeah.
When I've seen it again, that means I have, basically, if I've seen -2 here, and I've seen -2 here, I have a subarray. That means I went down and I went back up.
Okay.
Oh,
Right.
okay. Okay.
Okay?
Right. So there's been a pair, like a binary pair.
Exactly.
Okay.
So instead of 0 and 1s, we're looking for -2, -1s.
In that case, we're just using -2 here.
Okay.
Yeah. So here, if I have a graph, and I see a number here, we'll call this number 1. I go down, this is 0. Can everybody see my iPad?
Yeah.
All right.
Yes.
I come back up here, I have a 1. So between here, I have a subarray. Everybody with me?
Yes.
If I keep going down here, this is -1, this is -2. I get to -2 here, I go back up here, I go back up here. I've seen 1 before, correct?
Yeah.
All right, now I need to say this is the longest array, subarray. Because no longer is it.
There's equal values of zeros and ones to get to that point, right?
Exactly.
So they don't have to be next to each other. They just have to be equal.
Equal count.
Oh,
And then the count would be on this axis, the count would be this guy, and the index would be this guy.
so it doesn't necessarily have to be next to each other, not like 0, 1, 0, 1.
No, it doesn't have to be.
1, 1?
Not at all, because over here, if I have 1, 0, 0, 0, 1, 1, this is fine, correct? Do you agree?
Okay. I thought they had to be right next to each other.
No, they'd have to be
Yeah.
next to each other.
Okay, that's so then, all right.
It just has to be in that subarray here, it has to be equal.
Okay, so like 3 1s and 3 0s.
Yep.
Yeah, this makes sense. This graph cleared this up. Thank
Very
you.
good, very good. As long as it cleared it up, that makes me happier. Okay, so drawing is a lot, right? Cassandra knows drawing says a lot. Okay, so let's go continuing. So we agree that now the next step is to use our frequency dictionary to store values.
Yeah.
Yeah.
All right, so let's go ahead and we'll just say keep track. So here I'll say index, scene index. And we have our frequency dictionary. We'll use the count. So here, when we say frequency dictionary, give me your value, the value is going to be the index where we first saw it. Everybody with me?
Yeah.
Okay. And then here, if I haven't seen it, I'll just go ahead and store it. Here, first time. And now, now we will go over to do the maximum value. Are you guys hearing feedback?
No.
Not that much. It's fine.
My headphone is acting up. Okay, so now we need to go to step 1. We've done step 2 already. Step 2 was just assigning them if we haven't seen them. Step 1 is actually returning the maximum value using the max function of the maximum length we have already and the index we're looking at right now. All right, so let's go ahead and do that. So maximum length equal to the max function. We're comparing the max length with index, the current index. I should probably just call this current index. Let's just call this current index. Current index minus first in index. Okay. And first in index, current index, sorry. Let's see. Any questions before we test this out?
The max.
This guy?
Yeah.
Isn't that a
Oh,
built-in
it's not
function?
built in.
It's a built-in function. It returns the maximum of 2 values. So for example, max of 5 and 9. What is that gonna return?
9.
A lot of time saved.
Right, so that's gonna
A lot
be
of times.
cool? Yes?
Yeah.
All right.
Yeah.
Cool. So let's use the same example we had. Let's call this find, print, doesn't really matter. Find max length of 0, 0, 1, 0, 1. Oh, we had a 0. We had a 0, right? 0. Okay. Let's run this. And here we got 4, which is what we agreed that was the answer.